So my presentation is going to be similar to what Ole just went through, like sort of a live demo of our 3D scanner here, but our scanner is a structured light scanner similar to what Steve and Giles were using, but not as advanced from what I can see, but at least it's here and it's open and you can come use it anytime you want. And I'm going to run through it so you can see what it's good at, maybe what's not good at, and so you can make a determination if it would be a good fit for projects you have coming up or that you're thinking about. So I'm on two separate computers because we have a desktop PC here and it's a PC only software, but the monitor for the PC doesn't have a webcam. So I'm using my laptop so you can see me, and then I'm going to like screen share from the desktop. So I'm going to show you what the scanner looks like here. This is it. It's pretty small, maybe like 1.5 feet long. And this is the actual scanner up here. And then this is where you place your object to be scanned. So I'm going to log onto the second account and start my screen share. Okay. So our scanner is called the Ironscan SP. It's made by a company called Shining 3D. And this is their software. And what this software does is basically just take the scan and makes it into a functional, STL or OBJ file that you can use in a different software. It's not very good at, adding texture, editing anything. It's just good at getting the actual data and then making it into a 3D file. So we'll just select this scanner. Just booting up here, so it'll only take a few more seconds. Okay, so we'll go to new work. You can do open work if you had something saved, but we don't. So we'll do new work and we can call it angel scan because what the object we're scanning is a little angel figure. I'll show you here. Oh, can you see my webcam at the same time on the second computer? Yes. Okay. So here's like our object. It's, maybe 6 inches tall, 5 inches tall, but this is what it looks like. So press new. And why is it say the device is offline? Okay. So this is part of the problem with this scanner is that the software doesn't run smooth enough or fast enough for complicated objects, like anything bigger than what the scanner can see, or won't really work, because then you have to take the scanner off and take multiple scans, and the software is not fast enough or smooth enough to combine those in any way that's functional. So all I'm going to have to do here is close the software and then restart the scanner and then just open the software again.
As a CS major, and the unplug replug thing is probably one of the most useful technology pieces. Even going on from graduate school, people would ask me to fix their computers. I'm like, well, it's not really what I do, but I mean, I can run some basics.
I'll start my screen share in a second. I'm just going to go through the sort of like reboot up phase that, no, you don't really need to see it. And hopefully it'll actually be working, and then I can just get along with what I had planned. So.
Can I ask a question while we're waiting?
Yeah,
go for it.
So I get inquiries all the time from folks wanting to 3D scan objects and then edit them and build on top of them so they can 3D print them. What are the tools around that enable that kind of creative work?
Yeah, so we have I'm not sure how good this application is for 3D printing as a final result, but we do have an application. Well, we have SolidWorks here in the lab, but we also have Cinema 4D, which I don't think we'll have time to get to, but I'll talk about a little bit at the end, which allows you to sort of take a generic 3D scan and do what you'd want to do is like edit it, you know, add 2 heads to the angel or something, like copy, like a mirror it, or make it a different color, things like this. And we have that here. So if that's something that people would be interested in, we can do it here. Okay, so I have the scanner back up. Give me 1 sec.
Was to add on that, I wonder if at the Wondery there also might be some resources. That was actually one of the questions I written down myself to kind of follow up about.
Yeah, and Kevin, on the computers we have here, we do precisely those kinds of things. There's a lot of different programs depending upon what the result is that you're looking to get to take it from a scan to a computer generated model to a 3D printable model.
Okay, should I kind of continue?
Of course.
Yeah, okay. So usually when I had to skip a step because again, the software wouldn't allow me to exit without asking what kind of scan I wanted to do. So there's 2 types of scans you can do, which is textured or non-textured. For this presentation, we'll be doing non-textured because it's the same process, it just is faster. What a textured scan is that it'll actually shoot colored wavelengths of light as structured wavelengths, and you'll actually, in this final scan, you'll see it'll be the color, you know, you'll have all the colors that make up the object you're scanning. And a non-textured scan, it's the same thing, just it'll give you a sort of generic, you know, blue looking color that will just be the form and shape of the object. You won't have the colors and things like that, but you will have the features and the forms and everything like that. Anyways, usually when you first start up the software, you'll have something like this and this little preview window with some red spots. And this is showing that these spots of the object or the image are too bright to get information from, like those highlights are being clipped. So what you always have to do is take the slider and can play with it so that you get right below the point that you're getting this red clipping area. So like right here, you want it bright enough that it can see what you're trying to scan, but not so bright that you can't get detail in those areas. We'll turn HDR on anyway. That will, you know, the scanner will go through various levels of brightness to get the best possible results. For align mode, we'll do turntable coded targets. And what the coded targets are these kind of dots along the turntable that allow the scanner to position what the actual object is that you're being scanned. It's not going to go for something here in the background. It's going to know that, oh, this object right between all these dots are what should be scanned. There's other features, there's other modes here also, such as markers would be like the only other one you'd actually use, where you take these stickers, they peel off and you can place them on objects, on an object that wouldn't fit onto the scanner turntable. But like I said, I don't think the scanner isn't really that good at that because the software isn't fast enough or smooth enough to really compile all those images that you would have to, you know, place the scanner and do manually to get. Now, turntable steps are how many times the turntable is going to turn, you know, throughout 360 degrees, basically how many images you're going to get. So obviously the more turntable steps you have, the higher quality or the higher detail, higher resolution scan you'll get. But for our purposes, 8 is good enough for now. So once everything's ready, we'll go to start scan, and I'll try to like kind of move the laptop here so you can see how this works. It's Stephen Giles had a good video, but you can see, I don't know if that's coming up, but you can see the sort of different kind of patterns of light that it's shooting at the object to sort of get an idea of what it's seeing. And in the software, it's running through that HDR, sort of going really bright and then really dark also. So this will take, I don't know, like a minute or a minute and a half, just to go through the whole object. And you know, pick up all the information that's needed to make the scan. I don't know if anyone has any questions, you can, I guess, ask now while we're waiting.
Yeah, I mean, I'll ask, and yeah, it can kind of be for anyone who's presented. One thing seems interesting. We've kind of gone around the spectrum in terms of like accessibility and costs and things like that. So, what are those ranges looking like? Because I imagine like, Stephen and Giles, tens, hundreds of thousands of dollars. I'm unsure, but like it seems like there could be some very expensive equipment there. But then also you have your iPhone apps and things. So yeah, just kind of comments on that and potentially Vanderbilt accessibility within that.
Yeah, so the Paliga scanner, I think they're a kind of a young company and they're really great to work with. They really were, gave us a huge discount. I can't remember, what was it, Giles? It was like 15 or 20,000 or something like that.
Yeah, I think it was like I think even 26,000 Canadian. I think they're out of Vancouver. But yeah, I think they dropped it down to like less than 50%. So it was, and this is kind of like the tail end of one of their models. So it's really they're putting together bits and pieces from other suppliers to put together the system. The real power behind them is their software, FlexScan 3D, which does a lot of the I mean, as you're seeing going on the screen here, but it's dealing with it and you can manipulate them and change it.
Yeah.
So yeah, it's pretty, it's not exactly costs. The barrier is a little bit high, but their clientele is a lot largely engineering from what I gather. So you can scan at low resolutions, but this allows you to get down to really small models as well. And the cameras actually can shift position. So you can have them set far apart for larger objects. You could scan parts of rooms, a whole car essentially, or down to a small model like this. And it's kind of more of a fixed position. So it's a little more flexible. They had other versions that were very much like the Ironscan, where they're fixed for small objects, and that distance is also fixed. Yeah.
How
Yeah, in
accessible
terms
to
of
the campus
access,
community are they?
in terms of access, yeah, it's definitely a resource people can use. Right now, we're working on a project with Angela Sutton. That's this Bass Street project and Fort Negley project, looking at the African American community that was next to Fort Negley from really the turn of the 20th century to the early 1960s. But yeah, if you have a project that you need, high resolution scans, certainly get in touch with us. And it's housed in Garland Hall, in the second floor of Garland Hall, in the archaeological teaching lab. Right now, we're probably going to get displaced out of there. Everyone is. Garland's going to get remodeled next year or the year after, but that's where we are. So yeah, just reach out to us.
And we've had 2 undergrads who are become experts in using it. There's a small learning curve in terms of calibration, that kind of thing, but within an hour, you're ready to roll.
Okay, so our scan's done here, and there's obviously some parts that are missing, but this also isn't a completely meshed 3D model yet. If we were to zoom in here, you could see sort of those 3D data points that Steve was talking about in his presentation. That's what the scanner picks up and just makes an image out of that. So once we go through the meshing process, which we'll do at the end, most of these holes will get filled up, or the data that we're not seeing will be there. There are some parts, if you maybe were paying attention, that like the camera wouldn't be able to see, such as like the top part of her head here, or certainly the bottom, where the camera just never saw. I think for time's sake, I won't go through it again, but what we could do, and this is what the scanner is really good at, is we could do a second scan of the same object. So whereas before the angel was sitting on the scanner like this, we could place her like this perhaps. And that way when we would turn and we could get the bottom and then like the top of her head, and maybe like right here on the top of the book that the camera didn't see or had a hard time seeing. In the meshing process, the software will actually do a good job at filling up these holes. You just won't get all that detail that maybe you would want or need, but it's very easy. It combines the 2 automatically. Like I said, as long as it's on the turntable, it's very good. If you were taking it off the turntable and trying to do a bigger object, that's where it gets quite difficult. But in most of these scans, you'll always have some details or some things that you just know shouldn't be there, like these kind of rings. that it picked up. So what we'll do is we'll go in here and we'll hold the shift key and just click and kind of drag in, we'll do delete selected data here, and we'll come in here and just do the same thing with this little ring. Okay, so we'll press apply edit and global optimization, confirm. And here you can, it gets more advanced, but it's also kind of like I said, it's not the best software in the world. So I don't really play around with, if we had multiple scans, we could do a line manually and other things like this. I just let it do its thing automatically, and I think it works better than anything I could do manually. Now, once we're done and ready to save as STL or OBJ file, we go to mesh, and we have two options. We'll go with watertight since we want to close up all those holes and things that the scanner didn't get. If we wanted to leave something out or choose what we wanted to leave out manually, we do unwatertight, which would, mesh certain things and not others, or leave something open. For time's sake, we'll just do medium detail, although it's not going to take that much longer to do high detail, maybe like 2 or 3 minutes more. But since we're kind of pressed for time here, I'll just, for the sake of demonstration, medium detail is fine. And it'll take all those 3D data points and actually build the functional 3D model and file that you can use in other applications.
So I'm curious, are some of these technologies, and I know Kevin, you mentioned their requests often, where are you seeing those flow from? Because I can definitely see like engineering or even MBA, people trying to build products and want to do things like usability evaluations of, what an item might look like, wanting to do some of these quick scans. So do you know where they come from?
Yeah, I mean, ones I see are like things that people are trying to customize. So they want to make, say a prosthetic or something that's going to adapt to a limb, and it's going to be, very specific to that individual. I get a lot of requests. Can we 3D scan it? And, it's not something that, I guess it's going from the 3D scan to the design. So that's another level. Like, how can you then create like if you're trying to 3D scan the limb, take that geometry, create the offsets you need so that you get a nice comfortable fit. So you want to put some sort of foam lining on there, and they have basically full control over the whole digital model, and make cutouts, mounting points, add on the extra features that you want to make that that prosthetic or that design or tool usable. So. And then I guess another thing would be just like legacy parts of stuff, maybe pieces of equipment that aren't made anymore. Something's broken, I want a scan of this thing, so that way we can just 3D print new pieces again, rather than having to start from scratch and build the whole parametric model of the thing.
So here's our final file and model that we can use to either go to 3D printing or take into even SolidWorks or another app like Cinema 4D. As you can see, like this part that I was talking about, the top of the head that the camera had a hard time seeing, it did mesh, like it could fill it up, but as you can tell, it sort of just guessed what the shape should look like. It doesn't have this higher level of detail like that the camera actually saw, like around here. So if you're looking for a high detail scanner, you want everything to be detailed, or you want the color here, you're going to want to do a second scan, and I'll have the software align it. The bottom part is easy, I guess, for it to guess what's there, because it's just the bottom that's flush against the ring that's created by the features. Now, the important thing that I wanted to show is that the wings of the angel here, which I'll bring it up close, the scanner had a hard time seeing that because they're too thin, and a lot of the light just kind of passes through the holes and it can't get the wires, but it can get sort of where it gets bunched up here at the back. It did pick that up. That's one of the things that structured light scanner has a hard time doing, is anything that's reflective or transparent or not big enough for the light to sort of bounce off and hit the camera, it's going to have a hard time getting. So if you wanted to take a 3D scan of like a water ball, for example, you're not going to get, it's literally not going to come up with anything because the light's just going to pass right through it. There's other things we can do here, some basic kind of editing, like, you know, we can sharpen it, give it a little bit more of like a quote, artificial detail, but that's pretty much the process, and we can then save it. And here we can have, there's a whole bunch of different kinds of files that we can save it as. So STL, OBJ are I think the most common, but there's these other ones too. So that's the process of the Ironscan scanner.